Hello everyone, I'm Shivangi and I'm a PhD student at TUM. And um, and this talk is going to be about one of the problems that we face on social media every day, that is misinformation. And more specifically, I'll be talking about one special type of misinformation, which is out of context images. So I'll discuss what out of context images are and how can they be detected. And this is a joint work with my advisors, Chris and Matthias. And I come from an academic background, but I've tried to make this talk as easy to follow for people from non-technical background. So even if you don't understand anything, feel free to ask me any questions during or after the talk. And you can find more information about the project at this particular website. This is the project page. So you can go there and you can find everything about the project there. Why do we want to detect the out of context images? So we're all living in digital era, right? And we consume most of our information, most of our news via social media platforms like Facebook, Twitter, and so on. But we don't know which of the articles are genuine, which of the articles are identified as true, and which of them are false. And currently, to identify which of the article is true or which of the article is false, what big companies are doing is they are giving this as a task to a third party, which is fact checking organizations. And these fact check organizations basically regulate and look at each of these articles and identify whether they are true or false. So this way, companies are spending billions and billions of dollars on identifying fake media. And what we want to do is with this project, we want to make these things automatic so that then the fact checkers only need to verify what the model has made a decision about. So when we talk about misuse of images on social media, there are basically two things. So first is the image tampering. And in image tampering, what happens is people just play around or change parts and regions of the image to convey a different message or to misrepresent the person. And an example of this is the image on the left, sorry, where the original image was of a student holding a banner that says Black Lives Matter. And this was tampered to show that this student is holding a banner that says Lincoln was racist. And there are a lot of methods and tools and techniques that detect these kind of image tampering. So this is not the focus of our task. What we are interested in is the second image that you see on the right, which is the genuine image with irrelevant claim. And the idea behind these images is people do not play around with the image, they do not tamper the image, but what they do is they take this image and they share it with a news that this image is not at all associated with. And this news could be true, could be false, but is not linked to the image. And this is basically called out of context use of images. And so an example is this image on the right, where the actual image was from 2016 during anti-Trump riots. And this image was shared with a caption that says that people in migrant caravan are burning American flag. So this is the focus of this talk. How can we detect this type of misuse of images? So this is how we define out of context images. The images are legit. There's no tampering in the image, but they are shared in false or misleading context. And so this is another example where you see an image of Obama, and this is an image from 2014 where he was in Maryland and he was there to learn about Ebola vaccine. And after the outbreak of COVID, this image was shared with a caption that says that this image is of Obama visiting Wuhan lab in 2015, and he's discussing something about that project. So this is the kind of misuse of images we want to detect, where the image is legit, people don't do anything with the image, but what they do is they share this with a false or misleading information. And then there are like some more examples. So the image on the left, you see this is basically an image of Japan after the earthquake and tsunami happened. And this image was shared with the claim that this shows the that this shows the garbage patch in the Pacific Ocean. And again, there's another image, which is this image on the right. And this image is actually of a Triceratops puppet in a dinosaur theme park in Indonesia. When this image was shared with a claim that this is basically showing a Triceratops in Indonesia, a real Triceratops in Indonesia. So this is the kind of thing about out of context images. So people just take old images, recycle them, and share them with false claims. And this is the thing that we want to detect with this project. So if you look at, so we know the problem, and what we can do is we can go about build supervised models. We can say let's take images, let's take captions, feed them to the model, and ask the model to predict out of context use. But if you look at the other methods that use supervised techniques, they use lots and lots of data. So for instance, if you look at image classification, the ImageNet has like 14 million images, and ImageNet is the data set that people use to benchmark for image classification. And then if you talk about object detection, segmentation, then people use MS-FOCO. And this is also a very huge data set. It has around 300,000 images. And if we look at the images that are shared on social media every day and compare these images with how many of these images are used to spread misinformation, there are very tiny subset, very handful of images are used to spread misinformation. And currently these are, as I said, these are being regulated by fact-checking websites like Snopes. So we have very limited training data given the nature of the problem that we're trying to solve. So for detecting out of context use of images, we don't have enough data to build a supervised model. And to give you an estimate, there are around 300 million photos that are shared on Facebook every day. And this fact-checking website, Snopes, has, till the date I collected this data, had around 13,000 images as fact-checked in total. So you see the difference, that there's like a lot of difference between images that are shared versus images that are used to spread misinformation. So the idea that goes around this project was that why can we use these 300 million images that are not misleading, that are not fake, to somehow build a model that ultimately helps us detect the out of context use of images. And so basically these are not misleading, and these images, and we don't know if these are misleading or not actually. So we just know that these are images, and they have these images have several claims or several news articles that they are shared with, and we somehow want to leverage this to detect out of context use of images. And so the idea that goes around is we want to build an unsupervised or self-supervised training scheme, where basically what we do is we collect a bunch of images and we collect different captions or different information that these images are shared with. So for instance, on the top, you see an image of a train accident, and this was shared with two captions. So first was that rescue workers at the site of train accident at Great Belt Bridge in Denmark. So this caption is talking about the rescue workers in general. And the second one said that the passenger train was stuck by a cargo container in Denmark early Wednesday. And this caption is talking about the train. And if you look at the second image, this is an image of a scooter. And this image was shared with these two claims. So electric scooter programs have become popular in crowded cities like San Francisco. And this is talking about scooter itself. And the second caption, that a scooter on the sidewalk in downtown San Francisco. So this one is also talking about scooter. And what we do is we basically somehow try to associate different captions in our data set with the image. So we see that the top two captions, the rescue workers and the passenger train caption, is positively associated with this image on the left, which is an image of train accident. And the bottom two captions, which are about scooter, are positively related to this image of scooter. But not true, but this is not true vice versa, right? The scooter captions should have a negative relation with the image of a train accident, and the captions about train accident and workers should have a negative relation with the image of scooter. And this is the key idea. And why do we want to learn this association? This is basically, we'll look at test time. I'll explain that this eventually helps us to detect out of context use of images. So the training setup is relatively simple. We take an image and we take two captions. We call them matching and non-matching caption. And matching caption is basically the caption that appeared with the image in some social media post or news article. And non-matching caption is simply a random caption that is not associated with the image. And then what we do is we basically use a pre-trained object detector network to detect objects in the image, what objects are in the image. And then we basically use a feature extractor, which is a CNN network, and we extract features for each of the objects in the image. And at the same time, in parallel, we use a text encoder to encode these text articles. And so in the end, we obtain a 300-dimensional vector, both for all the objects and for these textual captions. And then we combine these textual captions with the features for the textual caption with all the features for the objects. And this combination is done via dot product. And then we simply apply a max operator to get the score. So these scores basically tell us which object is most relevant for a given caption. And we train it with laws such that the score for the matching caption is higher than the score for the random caption. And this basically helps us learn grounding of the objects in the image. And so this is so here I'm going to show you some visual grounding scores that the model has learned. And the image on the left, you see a train accident. So the top caption was about rescue workers, and it identified and gave a positive score to the worker here. The bottom caption is about the passenger train, and it gave a positive score to the passenger train. And you see that both of these captions are not misinformation, but they identify different objects in the image. Similarly, this image on the right, so the top caption is a large mural depicting a person wearing a mask, which is talking about the mural, which is the painting in the background, and it gave a positive score to that. And then the bottom caption, a woman walks past a mural reminding residents of anti-coronavirus hygiene. This is talking about women, and it gave a positive score to women. So again, different objects, but not misinformation. And then these are the examples where I'm showing actually how images are used as misinformation. So the image on the center, you see that this is like in reality, this is a photograph showing soldiers wearing exosuits, and this is from a movie. And the bottom caption, which says that a photograph shows Russian soldier wearing exosuits in Syria. So both of them are talking about soldiers who's wearing exosuits, and both of them correspond to this person. And on the right, you see that there is a person who standing on the streets, and this is in reality is an image from Tokyo. And at the bottom, you see this image was shared falsely that says that the image shows a Supreme Army General of Antifa in Portland. And both of them identify with this person. So now, once we have identified which objects are the captions talking about, we develop our testing strategy. And what we do is we take the image, we take both of these captions, we pass it through the model, and we detect out of context use of images. And the way we do this, we detect objects, we take both the captions, we compute features for these objects, and as well as these captions. And then basically we identify which is the most relevant object for each of these captions. So with this red box, you see that this is the most relevant object for caption 1, and the second one you see this is the most relevant object for caption 2. And then we additionally use a pre-trained sentence model that computes sentence similarity between the two captions. And we say that if the sentences are semantically different, but they identify with the same object in the image, then there's a strong signal that this is an out of context use of images. And otherwise, we say that this is not out of context. And that's how we detect our out of context images. So we were able to get pretty decent results. And this chart basically shows a comparison with a bunch of baseline methods. And our method basically goes to around 85% of detection accuracy. And 77% is SBERT is using only sentence baseline. And these are other detection methods. And what makes our method stand out from the other methods is we're basically dealing on object level. We're trying to identify which object the caption is talking about, whereas the other methods are treating the global context, and they're looking at the entire image in general. So I think that would be it from my side. And I have a news for people who are interested in these kind of problems, in this kind of tasks. So the ACM multimedia system this year is actually organizing a challenge based on this problem, based on this data set, and it's called Grand Challenge on Detecting Deepfakes. And they'll be awarding around 7,500 USD. So if you're interested, this is the link to the website. Just go and register and request the data set, and feel free to participate in the competition. So that would be from my side. I think we still have 2 minutes left. So if anyone has any questions, if not, I think I'll stop sharing my screen then. And if you have any questions, I know I rushed through it because we had like time limitation, but if you have any questions regarding the topic, please feel free to reach out. Okay. With that, I think I'll take a leave, and thank you all for attending.